Hello everyone. Today I'll be presenting my design for an intelligent agent system that supports anti-money laundering or AML risk detection. This system is designed to balance agent-based autonomy with strong governance controls in line with the principles of architecting and governing intelligent agent systems. Let's start with the overall concept. At its core, the AML AI system takes in three main types of input data: transactional data, which includes payment flows, transfer amounts, and timestamps; customer profiles with KYC data, risk scores, and known affiliations; external data sources like sanctions lists or adverse media. These inputs feed into the agent system, which has four core components: perception, knowledge, inference, and action. Perception involves ingesting and normalizing incoming data. Here we face architectural choices about storage and access. For high-volume transactional data, a NoSQL system may offer flexible schema and better write scaling. For customer profiles and compliance logs, SQL is better for consistency and complex queries. This is an example of making decisions and storage trade-offs in the system design. Knowledge represents the rules and models the agent uses. This might include thresholds for suspicious transaction amounts, blacklists from regulatory sources, historical patterns of known money laundering types. This component must be designed to be maintainable and auditable, supporting policy compliance. Inference is where the agent actually analyzes inputs to identify risk. This step can work in batch mode for daily risk reviews or in stream mode for real-time monitoring. Batch processing allows comprehensive overnight scans. Stream processing enables real-time detection and alerts generation for urgent threats. Our design supports both modes to balance completeness and responsiveness. Action is the part of agent that generates risk alerts. In the diagram, this is represented by alerts generation, which fits into outputs like risk assessments and regulatory reports. This stage is where identity and access governance becomes crucial. Alerts contain sensitive customer and transaction data. We implement policy-based access control or PBAC to ensure only authorized risk analysts can view or handle these alerts. For more granular control, attribute-based access control or ABAC can limit access based on user roles, case assignment, or region. These governance layers prevent data misuse and support compliance with privacy regulations. Governance also enforces policy compliance and observability through the system. Every alert includes metadata about why it was triggered, satisfying traceability requirements. Logs capture agent decisions, model versions, and data inputs, ensuring auditable rationality of behavior. Governance policies define threshold and risk rules, which can be updated centrally and version controlled. By designing the system this way, we enable the agent to act um, autonomously, screening huge volumes of transactions and generating alerts while still being bounded and structured by human-defined rules, data design choices, and access policies. This balance ensures the system is effective at detecting risk without sacrificing compliance, security, or oversight. In summary, this AML AI agent system reflects key principles of intelligent agent architecture. including design, decision, and storage trade-offs for data management, support for both stream and batch processing, strong identity and access governance using PBAC and ABAC, policy compliance, observability, and traceable agent decisions. By combining these elements, we create a robust, practical solution for real-world AML risk management. Thank you for listening.